All right, so this is our last panel of the day. Before we get started, I want to give you a little bit of background. If you've been around SDN for a while, there's probably one thing that you have heard over and over and over again, and that is SDN doesn't scale. We've all read it, we've all heard it. Despite everything that was said, despite everything most of us know, we keep hearing over and over again, but everybody knows SDN doesn't scale. So given I get this question over and over again, I thought that we'd take a crack at addressing it. And so I thought about how might we address that, and what does it really mean SDN doesn't scale? What would it mean for SDN to scale, and who would best know? And so what I did is I thought about a panel that could talk about this in somewhat of a unique way. Rather than say, yes, it does, could we actually explore this in a way that makes us all a little bit smarter? So before we get started, I'd love to ask each person to introduce themselves. Maybe we can start with Tom.
Hello, everyone. I'm Tom B. I'm from Tencent. I'm responsible for the solution and operation of Tencent infrastructure, including data center, networking, and the server operation. Thank you.
Thanks, Tom. Now, Brian Freeman from AT&T.
Brian Freeman from AT&T, general software architect for our SDN controller solutions, which you've heard about hopefully over the last day or so, out of Middletown, New Jersey.
Excellent. Before you say something, do you remember this gang of 6 from the last presentation? One of those gentlemen is sitting right here. Go ahead, Vijoy.
So Vijoy, I'm in Google Networking. I am responsible for all server-to-server networks, so that's all the fabrics and the WAN that connects them, and also network security.
Thanks, Vijoy. And Nitin.
Nitin, Serro, thank you for having me. The CEO of Serro, primarily a system integrator to get large-scale infrastructure solutions in an automated fashion to, I would say, large-scale enterprises.
Excellent. Thanks, Nitin. All right. So I've got a few prepared questions. Start thinking about your questions, because once we get through them, I'm going to want to take some questions from the audience. So the first question that I want to put to this panel is a relatively simple one, which is, can you tell us a little bit about what scale means to you, both you as an engineer, since you're all engineers, or former engineers in some cases, but also what does scale mean to you in terms of in your organization? Maybe we can start with Nitin.
Scale in terms of SDN, primarily, there are multiple attributes people look at, whether it is devices, nodes, or transactions. But there are other elements too, which one should consider, like SLA commitments or service agility that has to be considered. So scale is not one particular element. It depends on where your business is in time, and depending on which 1, 2, 6 of those elements need to be tweaked. That's where scale has to be looked at holistically. That's what we've seen coming as an integrator angle. So that's my thought around.
So you're saying it's not unidimensional?
It's definitely not unidimensional. It's multidimensional, and it's time-bound and business-bound.
Sure. All right, Vijoy.
So I think, again, agree here. It's all of the above. Actually, it starts a little earlier as well. So scale starts right from the time you want to figure out what your application needs are, what kind of hardware you need, what kind of architecture you need, start deploying the network you need. So even modeling your networks, figuring out how to deploy them, expand them, augment them. Scale is a part of that. And then, of course, once you've deployed it, then the SLA bits, the transaction bits, those come into play. How much data you can gather, how quickly you can gather them, how quickly can you react to them, all of that.
Okay. Brian, can you add anything to that?
You agree with everything that was just said. We think of scale also in these multi-dimensions, things like it's reliable scale, geodiversity, how do we get, clusters that have, fault-tolerant backup, persistent storage across the WAN, those kinds of things. are critical to us. It's not just the transactions per second and how fast you can drive things through, but when something fails, how fast can you pick up the load? What's the latency for your writes, all that good stuff. The other side of scale is getting enough developers who understand how to do this so that we can crank out features faster, move the market, faster, meet the business demands for what's being invented that use the networking and use SDN. So that's another aspect of the scaling here.
Well, you've just made the problem worse. You're saying it's not just the technology, you actually have to scale the people too?
Yes.
Darn it. All right. Tom, you know anything about scale?
Yeah, just think about it. Every year, hundreds of servers throw into data centers, and smartphone getting, smarter and smarter. CPU, better and better. So we generate so much traffic on top of the network. So we have to handle that much of traffic, and the network, server, they can just scale very easily, just number. But the network sometimes we stuck somewhere. So scale is also always our headaches.
Awesome.
So
All
I
right.
want to pick on what Brian said.
Go for it.
And I think you hit upon the organizational part as well, which I don't think any of us did. So scale from that aspect has two components. One is the organization has to move skill sets from where it was to something else. That's one aspect of scale. The other thing is it shouldn't be linear. I mean, if you're growing your network, your people shouldn't grow linearly, and then you've lost the battle. So it should be the reverse direction. So you should descale your organization as your networks grow. At least keep it constant.
Your efficiency has to go up as your traffic load increases, or it's not going to work. Because people expect the price per unit to go down as you go up.
Well, Vijoy, I'm actually going to put you on the spot here. Because so far, this is all great. I'm loving it. You're all agreeing with each other. I think we've touched every part of it, but I think we want a few more specifics. And so when people think about scale, Google is one of the first organizations in the world that people think of as high scale. Can you give us any more details in terms of, first of all, specifically from a devices, from transaction, from flows, from number of changes? Can you give us any specific, what does high scale look like in the world?
So I can't talk about actual numbers,
Fair
but ballpark figures, this was part of my presentation earlier. 10,000 switches.
10,000 switches is high scale.
Data center is typical. 250,000 links, connecting those is pretty typical. You would see million routes within a data center. We've seen upwards of 30,000 burst updates in routing per second, actually.
So a good solution that scales should be able to meet some of those kinds of
And
requirements.
this is just the data center. If you talk about the WAN, it's different.
A lot more.
league.
Okay. Maybe I'll go to Brian next. From an AT&T perspective, can you give us some sense? There was one, I think I may have mentioned this in my keynote somewhere, maybe not here, but there was a stat that totally blew my mind, which was how much data traffic goes over the AT&T network and how that's grown over the last 10 years. And the number that was quoted was from 2006 to 2016, I think, or 2007 to 2016, it was 150,000% was the amount of data traffic over the AT&T wireless network.
Yeah, it's been explosive growth, right? And everybody has seen it. Most of the places they're going, Netflix, Google, Facebook, going to all those places. Bearer plane traffic growing tremendously. Control plane traffic growing maybe not quite as fast because these are fat bits in a lot of cases. And we see nothing stopping it, right? People moving from flat photographs to video to 4K video and storing it for their personal journals, et cetera, so that now each home is going to have multiple terabits of storage in the home, and then they're going to want to post that somewhere, or they're going to watch and record movies on demand, long tail information, et cetera. So it's just going to continue to grow, and that's why for our Domain 2 program, we've set this bar to get to virtualization, because raw physical silicon is going to be a huge problem if everyone has to be customized, particularly if you put it in the wrong spot. Forecasting is only so good. If you put a physical PNF in the wrong spot, you can't really easily move it because you need screwdrivers and trucks. If I deploy x86 very cheaply and broadly, if I put a VNF in the wrong spot, I can move the VNF. I can move it and its traffic to new spots. So that's kind of why we want to be able to get to that level of scale.
Can I get any specifics from you? Can you share any sense of what scale means for AT&T in terms of any of those metrics we talked about?
Well,
Not to put
history
you on
is
the
a good
spot.
prediction of future, right? So if we're predicting 1,500%, there'll be even more in the 2020 environment. So it's an exponential curve as best we can tell. Okay.
All right. What about you, Tom, in terms of your environment? Can you give us some sense of what are some of the scale requirements for an SDN solution to be able to work for Tencent?
Every day, 2 billion photos uploaded.
2 billion with a B?
Photo uploaded, and it's keep growing, and the photo itself is getting bigger. And something like this make the storage very big, and the storage needs, sometimes needs, redundancy. All those causing a significant amount of traffic across the data center, which impose a large, significant exponential increase of the bandwidth. So we always lack of bandwidth between the data centers. So we ask our vendors to, can you make, the transportation, higher density, make the switch more density, all those things like this. So, so for sure, it's keep growing, at significant speed. So I can't give the number, but every year multiple times.
Right, multiple times.
Multiple times.
You overcome something and then you've got to go to the next level.
Yes.
Well, Nitin, I have a question for you. These guys are some of the highest scale organizations in the world. You've deployed a number of solutions for maybe more moderately sized enterprise. How do the scale requirements measure? Are they significantly smaller? What does high scale mean for your average enterprise?
I think so, coming from an SI that is closely working with space and defense, obviously we don't have the volume of data that consumers would be producing that they need to adapt to. The scale that we see is primarily about data centers are fixed assets, but then the remote controls are probably satellites and drones. And how do you actually have third-party APIs, whether it's three-letter government agency wanting to know when those assets are available to them, what's the weather in 15 minutes in real time, and making decisions in real time from some remote location. So we have control data based on third-party data. It's not like protocol control, but it's mainly the PSEP decisions before it can actually get into a protocol decision. So I think so the scale aspect comes to having 100, 150 third-party applications making a decision on what assets that are flying around the world to make one decision so that all the 200, 300 parties have access to in near real time. And those parties could be corporate enterprises that depend on the government to be in certain regions of the world. So I think so different type of a scale, but at that point, the scale is, we talk about people as network engineers, but at that time, you're talking about people as loss of life at that time.
Sure.
So
question for Vijoy. When Google began to build its SDN infrastructure, certainly you were probably one of the first to ever build one. This concern had been out there for a while that SDN couldn't scale. Can you talk a little bit about those early experiences? Was it just an invalid concern? Was it a hard thing to come over? Can you give us a little bit of a sense? I know you personally weren't there, but your team was. A little bit of a sense of how was it in the beginning, and how were you able to overcome the scale concerns at Google?
So a couple of aspects of that answer, right? So one is SDN is somewhat easier at Google because there is a lot of software we can leverage. Distributed systems software in Google has been there for a long time. And all of those things that were used for building large distributed systems for applications were leveraged for building network controllers. So we weren't reinventing the wheel in a lot of areas, so that helped. In terms of the motivation behind going after SDN, cost was a big factor. And deep buffer switches and building a WAN out of deep buffer switches, having expensive WAN links which are not well utilized. Those are issues that we wanted to overcome, so SDN gave us a way out. So using shallow buffer switches, the B4 WAN was built using pretty much off-the-shelf Broadcom silicon, not the Dune kind, the other kind, the XGS kind. And you could only achieve efficiencies on that kind of a network if you had global view. And having a centralized TE mechanism, having a bandwidth enforcer that did admission control and took into account usage information from all of these applications that were running at the edges, that made us push the utilization up, even though buffers were shallow and the links were expensive.
Right.
So I don't know if that...
Yeah, it does. So, I mean, in many ways, Google proved to the world that SDN could scale.
Right. And it wasn't, I mean, it wasn't a flag flip that we had SDN one day and everything moved on to this SDN backbone the next day. I mean, you went through a careful canary, you moved a few background processes like copy traffic and things like that, and then other kinds of applications moved over to this WAN, for example.
Sure. Now, for Tencent versus Google, Google had a chance to control everything, to build everything from scratch. When Tencent, a few years after Google, sought to implement SDN, you decided to leverage existing components from the community. Can you talk a little bit about your initial concerns, your initial questions about scalability, what your experience was, what you did to test, and your impression of how well SDN scales today?
Well, as your scale of your network grows bigger to a certain point, that's the point, we have to start thinking how to bring SDN into our environment. So we are lucky, that time I think the open community get to the point where it close to the mature, so we can take advantage of it. And the only thing we need to do is probably we need to have a team to fully understand, the open project and be able to maintain and fix bugs. So still many bugs you need to fix, and some features may not have, so you need to figure out how to work around. So those kind of things. But initially, we also wanted to write our own controller, something we did have that project, but we said, what's our main focus? So if we can work together with the community, so many beautiful minds, may have the better solutions. So we started using the open projects, and the result turns out actually the open project actually growing at very fast speed. Some features we can even not think of, but the community have that already. So make our adoption of SDN much faster if we keep hiring people write our own SDN controller. So that's the the thinking at the beginning. And once we started to bring the SDN into our environment, we have to think of a clever way. Anything new, it has weakness. So, but it will grow, and we think we have to make it in the appropriate environment. So we don't immediately let the SDN handle all the traffic trying to scale. So we do it step by step, bigger step next time. So we use incremental deployment, make sure it's okay, and so far so good. So we think in data center networking purely based on open flow. So far, I still think it's not mature enough, and it's not good time to do it right now. Maybe Google has done it already, but for most of people, it's not a good time. Maybe at this time, but rest of the things we have tried, and actually it's okay. It's okay. You don't. Usually we have our own in-house development systems work together with the SDN solutions. So we don't. We distribute the load. So make sure if it can handle it, we still have another way to handle it. So if it's grow better, so we move more things on top of it.
Right. So this is interesting. So you're saying SDN as a concept scales just fine for Tencent. but some approaches and some technologies you don't feel actually will scale to meet your needs. Like, and I think you cited OpenFlow. Do the rest of you agree? Let me open it to the three of you. Would you agree with that characterization?
I would, absolutely. I mean, multiple things. One is, as careful network engineers, you design for bad days, right? Things are going to break. So having two algorithms where, well, let's have the distributed algorithm from maybe old school handle something, and SDN does the optimization on top of it. But having, fallback plans, et cetera, are key. Do the testing and load and scale and performance testing inside your labs, because the open source community really doesn't have a good chance. They don't have all the equipment to be able to test the variation and the loads that you need. So you have to do that and report those bugs back to the community so that they can go fix things. But all those things factor into it can do it, but you still have to engineer it carefully and grow it where those places are risky. Where it's real solid, great, put the load on it. Where it's still immature, work with the community to work through the bugs, those load-dependent and scale-dependent bugs that they can't find through their normal, kind of unit and regression testing.
Others, do either of you have an opinion on this question?
So I disagree that OpenFlow is not scalable. We've deployed it at scale for more than 6 years now. Is it the best thing around, and is it the only thing you can use? No. Are there improvements? Yes. But to say that it's not scalable is, I think, a wrong statement. It probably depends a lot on how you've implemented it rather than the protocol itself. Yes, there are inherent problems with the protocol itself, but nothing that can't be worked around. And then on the point that Brian made.
Well, I'm sorry, before you move on, actually, if we can double click on it, Vijoy.
Sure.
Can you give us any more detail? Obviously, there are parameters. Why do you think people think that OpenFlow can't scale? And what might you have to do? What would someone do to be able to use OpenFlow at scale?
That's a difficult thing to answer for me.
Sure.
I know it works. There are.
Am I touching secret sauce here? Maybe a little bit.
A little bit. But it's not rocket science. There are. Okay. I think the room here knows what the problems are, and they can be all surmounted easily.
Fair enough. What's been your experience? You have to make these decisions when you're implementing in your customers, right, Nitin?
Yeah, I think it goes back to your first question about, what scale means to you and what time you're in. So if you were to go back to, the hydrogen days, assuming we're talking about ODL, it served one very great purpose around OpenFlow controller, had its limitations. You adapt to that because in that time, that was the best scale. Move forward in time, there are lots of applications. Are they perfect applications? No. You can adapt, you scale. You know what, as he mentioned, it's not rocket science, but we've done this in the physical world 15 years ago, 20 years ago. So it's adapting to meet the business needs today. And that could be driven primarily by large companies wanting to have 18-month cycles to get business advantage over something. So they'll go ahead and make that technology scale for that need. And whether it gets adopted by the community, who cares? Whether it dies after 18 months, who cares? Because we are moving on to the next one. So I do agree that it is not fully scalable, but it does scale, and you have to adapt for that time and that business need.
Right. If you're very specific on the goal that you're trying to do, you figure out the right technology to solve, and then you test it against that, you're able to get a solution that works.
Yes.
I have a whole bunch more questions, but I'd actually like to ask questions from the audience. It's pretty unique when you can get the individuals like these four individuals, representing these four companies up here to be able to talk about real-world SDN deployments. There's got to be some questions in the audience. One over here. Do we have a mic? Perfect. If you can stand up, please, and the mic is coming right to you behind you.
Thank you. One of the
can you give your name and if you're affiliated with any company?
Yes, my name is Ali Kafel. I'm from Red Hat.
Excellent.
This is a great discussion. One of the statistics that I've heard that caused the 15,000% growth in AT&T is actually from AT&T. And I think it was John Donovan I heard this from, who put it in this way. 1 minute of video is about an average 4 megabit, which is much greater than, the average text message is 20K, the average photo is 350K. But then he went on to say the next big thing is virtual reality. And 1 minute of virtual reality is going to be hundreds of megabytes. How can we handle that? Is ODL really ready for that? Do we need to have a different type of thinking? Are the current networks really able to handle that type of growth when you're going from 4 megabyte to hundreds per minute?
Has anybody thought about virtual reality here?
Oh, absolutely.
Go ahead, Brian.
I think we underestimate virtuality. I think we underestimate what Pokemon Go means to control networks. But by the way, bearer plane and control plane are two different scaling metrics, right? And so the bearer plane explosion that we're going to see with streaming video, virtual reality, and all of that stuff, that has that exponential curve, and we've got to put more glass in. We've got to be more efficient with how we do radio. 5G is going to help in some cases with the densification, et cetera. But that's a problem, and my boss will make sure that we solve those problems, right? But the control plane has almost a different scaling factor, maybe higher, because now not only will we have all those bit rates, but now the personalization of the networking so that we can give priority where you need to, move the bits around when you need to. That's, to me, the bigger SDN controller problem, not so much the bearer plane, it's the control plane. And now the virtualization, where do I want to move things? Do I want to spin up new video codecs because there's a popular movie, a popular virtual experience that's going on, spin up those new assets closer to the crowd that is observing them, bring those sessions together, mark that traffic. All of those things are going to be SDN controller activities. And so we will have to have federated controllers because you can't have one in Kansas City that manages that. And good protocols to pass and hand off and do all those other things. So I think it's solvable, but the control plane thing, I worry about more because of the personalization of the network than the raw bits. I don't know if
I just wanted to just a quick follow-up on that. So you've got this wonderful eComp white paper, right? And you've got all these architectures. Do you think you're going to need to throw all that out and start from scratch when we get virtual reality, or do you think you'll be able to stretch your architecture?
The reason we're doing things like eComp and open sourcing is we think it's not just the controller, it's the things that surround it. How do you detect, where the traffic is, where it should be, calculate the new analytics with machine learning, et cetera. What are we doing with respect to spinning up the assets? So it's really, you can't do it just with fiber and a controller. You need that surrounding ecosystem. So that's one of the reasons we're doing eComp is to handle all that traffic going through.
So I have two comments out here. One is around the revenue per user based on the expense of traffic being used is exponential. But still, providers or content providers need to provide the plumbing. We may call it a data center, we may call it a WAN, and that cost is also increasing. So SDN and the ability for that to scale such that you can use it on commodity hardware is going to reduce that cost such that at least the expense to revenue ratio is going to go down. Having said that, the WAN may not be replaced by commodity hardware. I know you mentioned around 1 million RIB entries. At internet exchanges, you're looking at around 30 million fib in, fib out. Commodity hardware won't be able to do that at that scale, depending on the exchange points. So that's one part. So ODL, SDN is going to scale to meet those needs when the demand arises or as it's arising. The second element to it about virtual reality, again, that's a great consumer problem that is being addressed. The second part of that virtual reality is also on the prosumer, which is a lot of industries, car manufacturers, for example, have very high intelligence GPUs on their manufacturing robots, and they could be 10,000, 15,000. But expensing GPU on-prem is very, very expensive. So if you were to actually consolidate, rather than consolidating x86-based resources, you consolidate a GPU such that car manufacturers can on-demand change whatever they want to produce the zero latency. You need the SDN capabilities at a global scale, and then that's where you have federated controllers to assist that. So to answer your question is whether it's virtual reality, whatever that application is, there is going to be some form of SDN controllers, and it's going to be federated at global scale. But if you think about, again, the defense, they are looking at larger scale from a space communication perspective too.
So federation is one way of solving it, and I think the virtual reality bit brings up the question around if you have applications of different kinds. So you can have machine learning applications, which is for us very different from a search or a Gmail. The architecture of the building block looks very different. And federation is one way of doing it if you have 10 different kinds of controllers. The other way to solve it is to have good abstraction layers in your controller, so that's an SDN problem, so that you don't have to, as your applications evolve, you're not hunting after 10 different kinds of controllers or changing your controller too often.
Right.
So I think working towards better abstractions is key.
By the way, this is why modeling is so important
Yeah.
to us in everything. And if you have a controller that doesn't have modeling, please stop bothering us. You need to have modeling, okay?
Tom, does Tencent think about virtual reality at all?
Yeah, for sure, for gaming, right?
Right, of course.
Tencent is. So yes, my thinking is, today to handle that much traffic, you have to put your service point or your acceleration point as close as possible to the end user. So you don't transport that much traffic to your data center, so you handle probably distributedly. And SDN only scheduling some, signaling and the content or the traffic. So it won't. I still think it can scale. And actually, in our cases, like a current video service, they don't have too many machines in the data center compared to other major businesses, but they consume a lot of bandwidth. Right. So that's the only difference.
Yeah, I got to say, I just installed 3 Nest cameras in my house. So I think I've just created a problem for 2 of you on this panel, right? You got to store it and you got to transport it.
Right.
Cool. Any other questions? I'm sure we must have some. Marcus, stand up and the mic is coming to you. Abby's getting her exercise.
Hi, my name is Marcus Williams. I work for Intel. I work on OpenDaylight, S3P, scale, stability, performance, security. My question is, I noticed that you guys talk about having people in your organizations who are working on sort of scale and performance of OpenDaylight. How do we create a pipeline that sort of gets more information from you guys who are using OpenDaylight to us in the community so we can improve the product, maybe improve our tests, improve the things that we're doing internally?
All right, that's a great question. So it's a community effort, right? Scaling OpenDaylight over the next few years is not about just where we are now, but where we are going to be in a year, in 2 years, in 3 years. How do we need to partner together to get there?
Well, I do think this is an area where the user community has to help. How can I expect you to load and performance test this new device that I got last week, right? You don't even know about it. We generally work through our distribution partners and we report bugs back that way, but that doesn't really help you as much with the design assumptions. And we probably need to, at the start of the carbon and et cetera cycles, each time, maybe work back through the advisory group and say, well, what would be the next gen performance numbers for BGP, for netcomp, for BGP speaker, BGP listener, stuff that goes on informally, Jan calls me or Colin calls, et cetera. But, and I know they talk to Tencent about scaling numbers, but make it a little bit more formal and start to say, what tests do we want to run? What performance number do we want to get to? Can we get to 50 million routes in a BGP rib for IPv4, right? That would be the kind of scale test you'd want to be able to run. Not that there are that many in the internet, but that there are use cases where you actually have to do, all this combining, et cetera. So that's what I would say.
Yeah, recently someone mentioned something that one of the ways that people are pushing requirements into OpenDaylight is they're just writing tests. And that when the tests fail, then Robert Varga has to go fix it. Anyone else want to answer or give an additional take on Marcus's question?
I just have a thought around it, but the Intel angle is slightly different. So you have vendors producing products. So the requirement or the ask would be, reliable, predictable, and let the community. So I don't know how Intel would fit into a vendor, but as the community validates those scale numbers and validates multiple products to produce the solution, because everybody has a product, but they may or may not interact. So it's up to the community to do that. So whether Intel is a part of that community or Intel is a part of Niantic driver issues or non-issues or actual scaling that aspect of it. But the way I was always looking at it is we have products produced by vendors, but not tested, not reliable. And when you take 2-3 vendors to produce something, as a community, we don't get holistic or consistent results at the same time. So I don't know if I answered your question as it pertains to yours, but I'm just looking at from testing vendor product and community testing from that perspective.
Nitin, I have a question on this. Your customers don't necessarily come to the OpenDaylight Summit, right? How much is it on you to represent their needs? And how much do you think, does every end user have to be engaged in the OpenDaylight project, or can SIs like you actually play that role to front that in a sense for them?
Yeah. I think it's very important for them to be here. But I think most of them come up with this huge 3-comma problem, and network is only 5% of that problem. And so that's not really worth their time. But when we actually propose solutions to them, ODL being one controller, multiple solutions, we also actively ask them to participate, because we, as an SI, are nobody compared to what their demands could be from other vendors that are there, right? So obviously, the defense contractors need to participate. We do ask them to participate, but then obviously some of the projects need security clearance, and so that message is very clear right up front that they should participate.
They should, okay. Any other questions from the audience? We have one right up here. Sir, can you stand up, please?
Yeah, my name is Parviz Yagani. I work for Huawei. And I normally use the example that I use for a controller like a razor, and everything that is used with the controller that people or the companies that can make money is the blades. So you have the blades and you have the razor.
Okay.
And we are hearing that how we can make this razor sharper, smarter, and more. How about the blades? So we are in the business of making money, collectively. So making the razor smarter and sharper and more diverse and globally unique, is that what it's all about? How about the blades?
I see. So your question, in a sense, is the technology itself could scale, but what about the solutions that people are building around the OpenDaylight technology?
So I think it depends on the business model one would like to explore. Fortunately, me and my team were in a very large web scale company. So we realized that SDN was a means for their main business. And they didn't really care if that blade was making money or not, but the cost per bit that was going through that blade, if that blade failed, was far too expensive. I'm talking about 25 million per second. So having said that, off loss, by the way. So if you look at the fundamental, and this is just my perception as a small SI, and is that the fundamental, if your core business is something else that depends on this infrastructure to be automated at scale to reduce failure or increase efficiency, then the cost of the blade may not be important to you, because you have other things that depend on that blade. So that's what we've seen traditionally, and that's why I mentioned about in the space and defense sector, they've got bigger problems, and we are just 4 to 5%, but that 4 to 5% is a large number.
Right. Anyone else want to weigh in on it? Should we take another question from the audience? Let's take another question. Anyone? Margaret, is this the first panel you haven't asked a question in ever in your life? Just kidding. All right, well, I'm going to ask another question. There's been a conversation around testing. I'm going to assume that none of you take our word or your vendor's word for whether we scale. So can you talk a little bit about what testing do you do within your own environment, whether it's ODL solution or a homegrown solution? What testing do you do? What do you expect from your vendor? And what do you expect from the community? Maybe Vijoy, I'll go to you first, since you've been quiet for a bit.
So I think, if there are APIs that are well defined, first and foremost is compliance to that API. So in that sense, a Plugfest is a nice venue so that you are assured of commonality. In terms of the testing that we do, there are various levels of that. We definitely, like any other organization, there are software-only test beds, there are hardware test beds. We are pretty creative and pretty aggressive in deploying these things in production. Getting less so with the cloud business taking shape and getting solidified, but most Google services have been written with redundancy in mind. So if things go down the wire, we really don't care. So we actually have used actual production environments for test.
And you have to do all your testing yourself, right? There is nobody else.
Yeah.
Pretty much.
So that's, and that's actually a call for the community as well. Features are nice, roadmaps are nice, but a well-engineered solution trumps everything else.
Good one. So, now, the rest of you have choices, right? There's stuff you do yourself, the stuff you do with your vendor, there's stuff you expect from the community. I think you've been involved on the AT&T side. Brian, you've been involved in some of the community testing as well as the internal AT&T testing. Can you tell us a little bit about that?
Well, I agree with everything. And by the way, I think the things on the functional side, like, your new certified ODL, whatever
Powered by
program, that's going to help a lot, because we want to be able to tell vendors who are selling us physical and virtual equipment, it needs to work with ODL, NetConf, BGP, whatever, make it work with that, so that we can get past the functional testing. So many times things show up in NetConf, partly works, or the vendor has a bad YANG model, and all that kind of stuff. But the scale testing in particular, we do a lot of scale testing because we have to, because generally in the open source community, you don't have access to the load generators. You don't have big banks of routers that you can use for launching traffic against. You do a lot with automated testing, with your frameworks, but in the end, it doesn't have the load variations in a lot of cases that we would expose. And we found that, just recently with some of the BGP testing, you flip this in the lab in a very, very rainy day scenario and bad things happen. So we got to report those back. I'd like an environment where the open source community had access to places where they could run some of these more standard scale tests. And then we could be doing the things that are really unique to our environment with our particular equipment. But the general kind of device independent kind of testing, I would want the community to be able to do more of.
Right. And it's not just ODL, right? OPNFV has the Pharos
Everybody
labs,
has the same problem. Yeah.
Right.
Yeah.
Tom, what about you? How have you been thinking about testing within Tencent?
We've been working very closely with our vendors. We usually rely on our vendors to do the first level of testing. Then we assemble a solution in our lab. So we use some kind of load generator to try to test it. But our opinion is that it's still not enough. So the best testing is in the production environment, but in a controlled way. So as we just mentioned, so you need to have a redundant solution just in case something failed, you have a way to switch over. So we always need to consider this. Then we put it in the real production to test it. That's the real things, and that will give you the real volume, real pressure. So I think if you want to make a system really scalable, right, you have to train it in a very heavy, very harsh environment.
Right.
Yep.
Just to add on to what you said, I should have mentioned, we do depend upon the distribution partners, our vendor, to do as much load testing as they can. That's how some of the revenue will be spread out, right? We like the security of being able to call somebody at 2 in the morning. We could download ODL ourselves and build directly, but we use a distribution partner, so A, there's someone to call, and B, they can do some of these kinds of tests as well, right? Because I think that is a critical part of the value prop.
Well, we've come to the end of the time on our panel. I don't think we have time. You wanted to ask a last question? Is it quick? One more over here. Oh, okay. Go for it.
Hi, Scott Christensen from Simon Fraser University, and I'm very interested in what you have to say about carrier grade and what service providers really need. So we're starting the Boron release, and I was kind of curious, you know, we've heard about scale as in capacity and setups and things, but what are the pressure points that you'd like to see addressed in Boron as far as the full carrier grade, like hitless upgrade, resiliency? What's the bigger pain point when it comes to failover of a link? Is like what kind of requirements do you have there? OAM, that sort of thing.
We have a long list of needs in that space for in-service upgrade in Carbon, and more and better geodiversity solutions. You know, better cross-site cluster sync. You know, there's actually a long list I think that's Colin is tracking in his set of enhancements to talk about for Carbon. It's better than it was. As he said, I think in the earlier speech, you know, we asked for migration utilities and documentation, and he got the documentation in Boron. They now recognize that they got to get, you know, even more on the in-service upgrade and failover, cluster diversity, you know, et cetera, kind of stuff.
And I think I heard Tom basically echo the exact same things at the end of his talk also.
Yeah.
All right, so I got confused. Is there another question here?
I want to hear Robert's question.
Go ahead.
It's actually not a question, it's a comment. I'm Lisa Kaywood, I'm the Director of Ecosystem Development for OpenDaylight. I just wanted to give you guys all a heads up that you'll be receiving an email at the end of the summit with a survey about your experience here at the summit. It's incredibly valuable for us, and I just wanted to make you aware that that's coming and ask you to please fill it out for us because it's extremely valuable for planning for next year.
Excellent.
Thank you very much.
Thanks, Lisa. So we've come to the end of our panel. I want to thank our panelists. It takes, I know it takes a little bit of courage to stand up there and share openly what you have to share, but also not get hurt by your lawyer. So thank you very much for coming up here.
Thank you.
Okay, thank you.